Hello, everyone. In this video, we'll look at some calculator tricks that correspond to Chapter 2 of the course. Most notably, I will show you how to quickly and precisely calculate normal calculations. It's actually a really cool way to get answers that are going to be more exact than what you can get off a formula sheet. I am starting on page 3 of the Chapter 2 notes. And before we get into normal calculations, I want to show you one other little trick. I'm looking at example 2.1.4, and we're not actually going to do anything with this examples or the numbers. I just saw it and it reminded me of something I could show you. So what's happening is, given a variable x here, it's x equals score. If we know certain statistics having to do with that sample, we can easily find modified versions of those statistics upon transforming data. So for example, if the mean of x is 42.8, what's the mean of 2x? It's 85.6. Now, you don't need any Ti89 tricks to figure that out, but if for some reason you did want to transform an entire list of data and it was in your calculator, there is a way to do that. So I have in my calculator here a list of values. It has nothing to do with the question in 2.1.4, but I'm going to just use this list to show you how you could very quickly double all these scores if you wanted to. It's very simple. What I'm going to do, I've got list 1 filled in. I'm going to scroll over to list 2. I'm going to scroll up until list 2 itself is highlighted, and then I'll go ahead and hit enter. And you'll notice that a prompt has shown up down at the bottom, which is going to allow me to define list 2. And one of my options at this point is I could literally say list 2 is equal to 2 times, and then I can hit second minus, go grab list 1. So I'm telling the calculator, hey, I want my data in list 2 to be all the values from list 1 just doubled. As soon as I hit enter, it does that for you. So really, any viable math operation that you could perform on a list of numbers, you could input that into a definition of a list. I could go to list 3 and say, I'd like to, let's try parentheses, go find list 1, close it off. If I want to square all those values, I could do it. All right. So just something to keep in your back pocket just in case. All right. Now for the main event in this video, let's scroll down. And again, we're gonna do examples you've already seen so you can confirm and check answers and whatnot. But I'm gonna scroll all the way down to page 6, example 222, the battery example. You can see I already have answers and work in front of me here. I have actually some answers from the formula sheet that I think we saw earlier in the year when we went through. We're going to now grab some calculator answers. Disclaimer here, the level of work that you have to show in writing is the same no matter what method you're using. If you use calculator tricks, you still have to show work. You have to show 2 steps that have P notation, one with X, one with Z. Show me a simplified Z, and then show me an answer and give me a 1-sentence conclusion. None of that changes. I'm just going to show you a quick way to get an answer. All right, so what we do in our stats app, we don't have to actually input any lists or anything like that. Instead, I'm going to go to F5 distributions. We can already see in there some options that say normal. In this course, we're never going to use normal PDF. Don't worry about it. It doesn't measure something that we ever need to find, but we will be using normal CDF, cumulative function for normal. So I'll go ahead and hit enter. And as you can see, there are 4 values we need to input. And there's actually 2 different correct ways to do this. I'll show you both of them. The first way involves using z-scores, which is what we did with the formula sheet. So for that reason, I need the inequality involving a z-score that I've got simplified here. I want to represent values of distribution such that z is less than -5/3. If z is less than -5/3, that means -5/3 is an upper bound I'm taking values that are below it. So for upper value in the calculator, I'm going to input -5/3. Well, what do I put for lower value? There is no set lower bound. I want to go as low as I can go. And in the Ti89, one way you can represent that is with -infinity. I'll go grab a negative sign and then green button, green diamond button, right there on the catalog key. There is an infinity symbol. If we are dealing with normal distributions in terms of z-scores, and this is the nice part here, mean and standard deviation are always going to be 0 and 1 respectively. That will never change as long as your bounds up here are in terms of z-scores. So upon hitting enter, I should see approximately the same answer as we had using a formula sheet. Let's hit enter and see what happens. There it is, 0.04779. I've rounded it to 0.048. Which is good. All right, let's do that problem again. I'll show you the second way to input this stuff. F5, back to normal CDF. Instead of using z-scores, you can actually input things in terms of the raw data instead. So originally question A was asking what % of batteries last less than 40 hours. So in terms of hours, 40 is an upper value. I can still leave -infinity as a lower, although now that I think of it, I think we discovered one year that if you just leave lower value blank, or upper value for that matter, it assumes infinity, or go as far as you can go. So I'm going to try that. Now the one change here is if I go in terms of raw data, I have to use the actual mean and standard deviation from the population, which I don't recall exactly what they are, but it looks like they were 50 and 6 based on my work here. I'm going to just to confirm, yeah, 50 and 6. So mean 50, standard deviation 6, enter, possibly twice, and you do get the exact same answer either way. I don't care which way you do it. You should know how to do it both ways. Regardless of which way you do it, you are still accountable for all the work that I've shown here. All right, let's do a few more of those. Next question, what % of batteries last more than 52 hours? Okay, back to normal CDF. More than 52 means 52 is a lower bound. So I could input 52 for lower, upper, I would put in infinity or leave it blank. If I'm gonna stick with raw data, which I have, I'm gonna keep 50 and a 6 here. I should get back approximately 0.369, and I do. All right, the third question, what % of batteries last between 47 and 54? This was a little bit trickier on the formula sheet, but it's not any trickier at all if you are using the calculator, because this just means you have a lower and upper bound both given. We put in 47 for the lower, 52 for the upper, keep my mean and deviation. I should get an answer of about 0.439, which I did not. So what did I do wrong? 47, 52. Oh, it's because I misread the question. I put in a 52. I meant to do 47 to 54. Let's try that one more time. Yeah, fix that error up. And now I'm looking for 0.439, and we've got it. All right. I'm going to scroll just a bit here. And you might recall these last couple questions on the page were a little bit different because you're working backwards. We don't have bounds given in terms of the data. Instead, we're given a percentage within a certain interval or above or below a certain cutoff, and we want to find what is the boundary. So there is a way to do that on our calculator. And if you go back to F5, you will notice that a couple spots above normal CDF, we have something called inverse. Inverse as in, let's go the other direction with it, right? So lo and behold, one of the options in there is inverse normal. Go ahead and choose inverse normal. Now you're still going to input a mean and a standard deviation. So I'm still going to keep the 50 and the 6, but for area, All right, here we have to input an area that lives below a desired cutoff. So this behaves the same way as the table from the formula sheet in that this number has to always be an area below. So for a battery's life to be among the top 5%, what percent could be below it? The cutoff for the top 5% is going to have 0.95 as an area below. Do a little mental math on that. Hit enter, and the results you get back, in this case 59.869, does represent the cutoff in terms of the original units of the problem to mark off the top 5%. So in this case, battery life in terms of hours. If your batteries last more than 59.869 hours, you are in the top 5%. The very last question here, finding IQR. What was tricky about this one is we want to find not one, but two cutoffs. We need a Q1 and a Q3. So you have to think of those two locations in terms of areas below. And we know that Q1 is the location such that the area or percent of the distribution below it is 0.25. For Q3, it's 0.75. So in a calculator, you would have to work through inverse normal again twice. The first time, go with 0.25, and you'll notice I get back, I should double check. Yeah, we get back this 45.953. And then you go through that process again. I'm going to skip it here, but if you go through again and set the area to 0.75 instead of 0.25, you'll get back this other result. Those are going to be your Q1 and your Q3. If you want to continue along with IQR, obviously we subtract those. All right, so there it is. Both normal CDF and inverse normal are the features that we use for all the various normal calculations we might come across. I'm going to scroll down a little bit more and show you one last thing real quick. Page 7 was a problem where we looked at a data set. It's provided up here on the top right, and we tried to determine if it's approximately normal. One of the things that we did here was we compared the spread of our data set to the empirical rule. We wanted about 68% of the entire distribution to be within one deviation of the mean, 95% within two deviations, 99.7% within three deviations. So when we did this the first time, it wasn't very hard to figure that all out because this data set up here is already in order. So I know maybe it's a little bit difficult remembering back to this stuff, but at some point we had calculated cutoffs in terms of standard deviations. But yeah, like I was saying, it was really easy to count how many of these numbers are between 12.174 and 13.391 because they were all in order. Now, data sets aren't guaranteed to always be in order. So what's a way that you could order numbers really, really quickly if you have a calculator? That's what I'm going to show you to close off here. If I go back to my Ti89, hit enter. Turns out that list 1 this whole time was in fact the list from this page 7. I intentionally typed the numbers in the wrong order. I guess there isn't really a wrong order, but I didn't list them in increasing order. So if this is how the data set had been presented, it would be really challenging to try and figure out how many of these numbers are between these two particular cutoffs. So again, what you could do with that is really quickly go to F3. I think we saw this in the last video. OPS operations. So just a reminder, sort list, list 1. You could choose ascending or descending. It is really quick and easy to put those numbers in order. And now you can scroll through and much more easily count up, okay, how many of these are between 12.1 and 13.3? How many are between 13.3, the next cutoff, so on, so on, and so on. All right, that's it for this particular video. Stay tuned for further videos for later chapters in the course, and email me if you have any questions. Thank you.